Hey, hi there. So welcome to this session on UVM Component Base Classes deep dive. So I know we have sort of looked at the component hierarchy now multiple times, and we have used them. We have looked some of the examples around it. This session is going to be short and quick, but what I wanted to do was like little bit look at the documentation and just formally showcase each of those component hierarchy to make sure that we are clear as to what each one of them is offering, right? Like for example, we have seen that like UVM EnV is not offering anything new compared to UVM component, right? Like we have been saying this, but in this session we'll just have a quick glimpse at it. Like for example, what exactly is UVM EnV providing, so that that concept that we have looked at sort of sinks in our mind better. I know the agenda looks long, but don't worry, it's going to be very short. We will be spending a very short duration on each of these components because we already know most of it about it. So we will be quickly looking at the component hierarchy in the base class library. Then we look at UVM component, and then we'll briefly look at what's the difference between component versus objects. Then we look at UVM test. All of these are essentially, the extension of UVM component. We look at UVM EnV Agent, Driver, Monitor, Subscriber, Scoreboard. Then these could be little bit new information, that how do we do the command line control, and like where do we spot all the macros and defines that we have been using, right? So with that, let's quickly jump in. So this is the base class hierarchy diagram that we have been looking at it for a while. Just wanted to put in perspective that what we are really going to be looking at. So we have UVM object, report object, and we have UVM component, which builds the hierarchy plus the phasing mechanism. And then we have this bunch of additional objects that are deriving UVM component. For example, we have test, we have EnV, scoreboard, agent, monitor, and your sequencer, driver. So a bunch of them, right? So all of these, like after deriving from the component, what exactly are they additional features are they providing? So we will quickly look at it from the base class documentation. We'll start off with the UVM component base class itself. These are the snippets from the base class library documentation. So UVM component is the root base class for all UVM components, and in addition to the features inherited from UVM object and UVM report object, the component provides these interfaces. It has the hierarchy control. As we have been discussing, the component is the one that forms the test bench hierarchy, because components remain throughout the duration of simulation, whereas objects gets created and destroyed. And that hierarchy is contained, that hierarchy information is contained within the component. So through component we can find out who is the parents, who are the children's. As you know, every time we create the component, we pass the name and parent. So through that information, the hierarchy gets sort of stored within the component, and this is that information. And second most important is the phasing, right? So defines the phased test flow for all the components. So here I am showing few of the functions that are related to each of these concepts. So like for example, you have get parent, get full name, get children, right? So all this different type of information can be utilized. Some of it is useful in some cases, but some of it could be utilized even internally within the UVM. But these are the like snippet of few the functionalities that are present in these groups. And then we have the phasing functions, as we have already seen: build, connect, end of elaboration, start of simulation, run phase, and those run phase parallel, the sub phases, so on and so forth, right? So this is the from the documentation. There's another reason why I just wanted to show you guys is that what we have learned is what's really present in the documentation. You should not feel that okay, I have learned something but I'm not sure what's there. So you look at documentation, you look at source code, and we have to be absolutely sure that the concepts that we are looking at is the way it has been defined, and it is a way it has been implemented in the base class. That's another reason why I wanted to quickly take you through each of these base classes, because I am taking you through only the important ones. I'm not taking you through the entire 300 base classes that are present within the UVM. Let's look at the differences from like objects versus components. So objects, typically multiple objects are created and destroyed throughout the simulation, exception of global objects. You could be creating like a global state object, those might be, or a global configuration object like what we had seen even in the UR test bench, that gets created only one copy and it stays throughout the duration of simulation. But whereas various sequence items that we had created, sequences that we had created, they all get created and destroyed. While we look at components, they get created once per test and typically remain throughout the duration of test simulation. And objects are typically transient, this is sort of another way of saying it, whereas components are semi-static, loosely similar to modules also have a static existence. And objects don't contain any phasing, so this is a very important point. They don't contain any phasing. Components are compliant to phasing. In fact, it's a UVM component that brings in all the phasing interface functions, as we saw in the previous slide. And for factory registration for the objects, we use the UVM object utils, and overridden generally by the type, as they are not part of the environment hierarchy. But for factory registration for the components, we use UVM component utils, and can be overridden either by type or instance. So this is also another important difference. And the default constructor has only one argument, name, for the objects, whereas the default constructor has two arguments, name and parent, for the component. So these are some key differences. I hope you pay attention and remember these. So the UVM, let's look at the UVM test base class. So the UVM test base class is, again, as we looked at, is the extension of the component, and all the user test case must be extended from the UVM test. When you extend from the UVM test, you can pass the test to be run using the plus UVM underscore test name argument, and you can pass the string, and through the factory it automatically maps it and runs that particular test. So apart from this, there is nothing much new that's part of the UVM test compared to component. This is the complete documentation. There are no new functions, right? It's just whatever that the component has provided. That's why most of the time we'll just end up populating the different phase functionality within the UVM test. Okay, this is the UVM EnV, and this is the documentation. This is the complete documentation snippet for the UVM EnV. If you see, it's a virtual class UVM EnV extending UVM component. Only constructor that's present within this class, that's extra. That's a default thing anyway. But there is no new functionality beyond what's provided by the UVM component. So that's the reason why, like even in our UR test bench, we were able to extend the UR EnV from the UVM component itself, and it doesn't make any difference, right? So as of UVM 1.2, there is no additional new functionality that is present in the extended UVM EnV apart from what's already provided in the UVM component. But the reason to extend it from UVM EnV is that when you look at that particular class, when you grab it in your class hierarchy, it becomes easy for me to spot that if a particular class is extended from UVM EnV, it makes the intent clear. And in order to do that, you generally want to extend all your test environments from the UVM EnV. That's one reason. Second reason is, in future they may add some specific functionality which is only applicable to environment and not present in the component, that you can utilize. So for all user-defined agents, we should be using the UVM Agent base class. I think the only, so this is a virtual class UVM Agent, extends UVM component. The main new functionality that it adds is really this is active type of a additional property, which helps us control whether it's a UVM active type of a agent or a UVM passive type of a agent. An active type of agent will contain both the sequencer and the driver, whereas the passive type of agent will contain only the monitor. And the UVM agent virtual class should be used as a base class for user defined agents. Deriving from UVM agent will allow you to distinguish, again, as we talked about, agents from other component types, also using its inheritance. Such agents will inherit the features that may be added to the UVM agent in future, right? So agent typically contains three subcomponents. It has driver, sequencer, monitor. If agent is active subtype, then contains all three subcomponents. If agent is passive, then the subtype will contain only the monitor. I think that's the information that we already discussed, and this is the snippet from the documentation. So that confirms our understanding. Okay, this is the base class for the UVM driver. So the base class for drivers, initiates the request for new transaction via UVM sequence item pull port. So we have class UVM driver parameterized by the request and the response type of sequence items, extends UVM component. So the new things, if you notice over here, we have these two new ports that we have used and looked at when we talked about the the sequence item sequence and sequencer and driver deep dive. So we have sequence item port, like that is derived driver classes should be use this port to request items from the sequencer, and then we have a response port, RSP underscore port. This also we had looked at. This port provides the alternate way of sending the responses back to the originating sequencer. However, you note that even when we did the sequence item port dot put or put response, it actually goes via response port itself. So that is something you can confirm that when you, by looking at the source code that is present within the UVM driver. So this is the base class for drivers, and I think this is the point that we have already discussed. Then the point to note is the driver operates in the pull mode. We have already looked at it. Then its ports are typically connected to the corresponding exports in the pull sequencer. So this is the connections that you make in the agent for both the ports within the driver. So I just wanted you guys to see that we have these two new ports on the top of what's already present in the UVM component within the UVM driver. So UVM monitor should be used as a base class for user defined monitors. Deriving from UVM monitor allows you to like distinguish, again same thing, like distinguish from generic components, and in future if there are any updates you'll be able to see it. But if you see compared to UVM component, in the UVM monitor there is no new functionality that is present, right? Even the analysis port that you need for sending the transaction, you need to declare it in this extended user defined monitor class, and that gets used up further. Okay, so UVM subscriber provides the analysis export for receiving the transactions. This is the one that we are talking about, and making connection to the subscriber, this component to any transactions emitted by the connected analysis port. So through this you can receive the transactions that are sent from the monitor, and this subtype class must define the write method, right? So the moment you have the analysis port is built in, which means that a write method, pure virtual method, will be provided through the interface class concept, and that write method must be populated, and that's a method that's going to be called by the monitor who is writing to the analysis port. Whenever he writes to the analysis port, all the connected subscribers write function will get called, and within that you can do any functionality. Like typically you will be end up doing the coverage sampling as a part of the UVM subscriber class. Apart from this analysis export, which leads to this additional write method, there isn't anything more than what's provided by the component in the UVM subscriber. So UVM Scoreboard is a virtual class, should be used for as a base class for your user defined scoreboards. It's also derived from the UVM component. There is no special functionality that is present within the scoreboard as of now. You will have to implement most of the functionality. Again, extending from the UVM scoreboard makes the intent of your component clear compared to the generic components, and could potentially benefit from the any future updates that happen to the UVM scoreboard base class. So if you remember in the system verilog test bench, we were using this system task called $value plus args, or the $test plus args type of a system tasks in order to extract the values or the flags that were passed on the command line that we use to change the behavior of the test. If we had any programmable part in the test, then instead of hard coding those values, we allowed the values to be received from the command line so that we can rerun the test in different flavors without we having to keep on changing the test and recompiling and running. So that's a very useful thing. In the UVM, there is a command line control object that is present. It provides interface to the command line arguments that were provided for a given simulation, and the generation of data structures which holds all these command line argument information happens during the construction of this particular class object. And this is a global variable that's present within the UVM. You don't have to do anything, you can just use it. It's called as UVM CMD line underscore proc. It gets created at the initialization time and may be used to access the command line information. So we look at one of the examples. So I'm declaring a queue of string, and then I am calling this UVM command line proc dot get arg values, and I'm passing the arg that I'm looking for called plus foo, and then I'm passing this queue of strings foo values because it returns the list. And then let's say this is the command line that I'm running. So I'm saying I'm passing this plus UVM test name equal to some name, and I'm passing plus foo equal to 1 comma s comma on, and then I'm passing one more time plus foo equal to 5 comma no comma off. And then once if I now print the foo values, which is the string queue, then I will be able to see these two, which were these two values that I had passed. So then subsequently I can sort of split this string and extract these individual values. But the point that I want to make are two things. One is you can use the same command line argument multiple times, and all of them will be gathered in a form of a list from the command line proc when you call this get arg values function, and that can be utilized. And then there are some string processing built-in functions, so you can use those string processing. We have seen those even in the context of system verilog, and even the UVM itself has some string processing functions, so you can utilize that to parse them further. I would not recommend that you pass information like this. I'm just showing you this as a possibility. I would recommend that you use individual values so that you can directly utilize them. But sometimes if you need to pass with a common command line argument multiple values, those you can do it over here. And I have seen the practical applications of passing multiple values. But you can, but the crux of it is you can use the command line proc object, and you can use the get arg values, and you can use whatever the argument value that you intend to pass on the command line and extract those values. The values will be returned as a list, and that you can further process to modify the behavior of a certain component or a test as per your requirement. We have looked at some of these built-in arguments already in the context of various discussions. Just consolidating it over here, you can use plus UVM test name to pass the test name that needs to be run, plus UVM verbosity to control the verbosity of the message filtered for the tick UVM info macro, and then you can use tick UVM timeout to set the global timeout. This we had discussed in the context of end of test. You can set a value and you can change it. And then you can use tick plus UVM phase trace to print all the phase execution. This is something that's useful while debugging. These are some of the control built-in arguments, and these are the debug type of built-in arguments. And then plus UVM objection trace will print who is raising the objection, who is dropping the objection. All that information will be printed in your simulation log file. And then you have plus UVM resource DB trace. So any of the, if you use resource DB because you don't care about the hierarchy, then all the get and set, which is very similar to what we saw in the context of config DB, all that accesses will get printed. And then you have plus UVM underscore config underscore DB underscore trace. So you can use this argument to print all the get set that happens within the config DB. So these debug arguments, this trace debug arguments, are very useful when you have the issues with the UVM, which you can utilize. Okay, so we have looked at few of the macros, few of the defines throughout our, the deep dive sessions, but we have not looked at comprehensively at all of them. There are so many of them, right? So I just wanted to list them, what are the different types that are available, and so that in future you know that these are the categories exist and you can go look it up and understand more about them. So we have the reporting macros, like for example, the UVM info, those I think we have looked all four of them. We have some global macros, like you can use it for setting the timeout within the code instead of passing it from the command line argument every time for every command line. And then you have component and object related macros. Of course, the factory macros we have used, field macros we have talked about in the context of the transaction building, but we haven't used it. So once you define all the fields for the properties within a transaction, then the do copy, do compare, do pack, do unpack can be automatically generated by using the field macros, which start with tick UVM underscore field underscore the different type of like int, enum, string, like that. There will be different set of macros that help you capture the field types and their size, various information about your properties of the transaction that you are building. And then we have sequence and do action. So we looked at some of these when we were building the different types of sequences. And then we have callbacks. We have not discussed this. Callback is a mechanism through which like you can register a particular function, and at that point that registered function can be called back from the UVM. This is one of the advanced features. And then you have the TLM. Then there are we had looked at, for example, the while we were doing the analysis port write, if you wanted a different name for the built-in functions, then they declare underscore declare type of macros can be utilized. And then we have registers related defines that are available, that you can configure the address bit, address bus width and data bus widths. And then there are a bunch of macros that indicate what is the revision of the UVM that is being utilized. Sometimes what happens is that you have the UVM provided as a like a precompiled library, and you might be experimenting with some different newer versions of UVM, and you might have gotten confused at which version of the UVM I'm running the test with. Then you can display these macros that pre-exist within the UVM package to showcase with what version of the UVM that you are running with. So that way you can utilize these defines and the macros. I'm just showing you the different categories that are present, that you can explore as you go along. Okay, so this concludes this session on the UVM components. I know there was not really much, but just I think like we got a glimpse of how the component hierarchy looks like, what are those different components, and then we understood that many of them fundamentally contain nothing more than what the UVM component provides, at least as of UVM 1.2. And we looked at the command line processor, how that can help you extract various command line argument values similar to the $value plus arc that we had seen in the system verilog. And we also briefly looked at various categories of the defines and macros that are present, that can be utilized. And importantly, we also looked at some of the built-in command line arguments which could help us set some of the controls, some of the like the timeouts, verbosity, test name, and then various trace command line arguments that help us do the debug when things go wrong with the built-in features that are provided from the UVM. So what happens is in UVM we are utilizing a lot of base class libraries which we may not completely understand. I mean, that is the intent, right? Like if I have to understand everything and then use it, I mean, why should I do that? Maybe as well I'll rewrite it. So many of the things work out of the box, but there are then things sometimes go wrong because of like maybe some human error. Also things can go wrong. In those cases, what happens is these mechanisms help us debug them better, or debug them with a ease. So those were the importance of the trace macros. So yeah, I think this concludes it, and thank you for listening.